Algebra 2. Today we're looking at applications of linear programming. This is the second part of your notes for section 3-4. Steps you're going to use for all these application or word problems. Step 1, you need to define the variables. Tell me what you're going to let x and y stand for. Number 2, you're going to write a system of inequalities called the constraints. Those will help you find the boundary lines. Step 3, graph those inequalities on the same coordinate plane and then determine the feasible region. When you're working word problems, most of the time these feasible regions will be bounded. So you're going to find the feasible region, and then next, find the coordinates of the vertices of that region. Coordinates ordered pairs for the points that define that space. Step 5, you're going to write the cost function, and that's always going to deal with money, profit, and you're going to use that function that you come up with from the reading to determine the maximum minimum value by substituting in the vertices. And then step 6, I need you to answer the question, of course, but make sure that you do so in a complete sentence. Example 1. Julie works 2 jobs, tutoring and delivering pizza. She works no more than 12 hours each week. No more than 12 hours. So that means 12 is the highest amount that she works. She wants to spend at least 3 hours, but no more than 8 hours a week tutoring. So she wants to spend the minimum amount, 3 hours tutoring, but she doesn't want to go over 8 hours a week doing that job. Next, she wants to spend at least 3 hours delivering pizza. Julie is paid $10 an hour for tutoring and $7 an hour for delivering pizza. Find the number of hours she spends doing both jobs for the week to maximize her profit. Find the number of hours she spends doing both jobs for the week to maximize profit. Okay, so after you read it and reread it, your next step is to define the variables. We're going to let x be the first job we noticed in this reading is about tutoring, so it's asking us to find the number of hours that she's going to spend doing that job so she can maximize her profit. So we're going to let x be the number of hours tutoring. We're going to let y stand for the number of hours delivering pizza. And that's basically all coming from the sentence, like the question, right in here. Okay, again, because tutoring comes first in the reading, that's why tutoring is x and delivering pizza is the y. Alright, she works no more than 12 hours each week. That sentence tells me that 12 is the max. That's the most hours she works. It also doesn't, it's not specific about which job, and so because of that, that sentence I've highlighted is asking us to consider on the constraint. One constraint is she's working to tutor, but she's also working hours delivering pizza, but it says she works no more than 12. And so if 12 is the max, that means we have to use, we can equal that amount, but we can't go over it. So that means we have to use the less than or equal to symbol. Okay, so that's one constraint. Next, she wants to spend at least 3 hours, but no more than 8 hours a week tutoring. Okay, so with the tutoring, it gives us a very descriptive like details. So I'm going to write this constraint here to the side. She wants to spend at least 3 hours tutoring. Well, I'm letting X stand for the numbers of hours tutoring. So X, at least 3, means 3 is the lowest she wants to go, but she can do more than that. So that's going to be greater than or equal to. So at least is actually greater than or equal to. Well, often the wording and the symbols, it may actually be the opposite as to what you think it would be. So make sure that you're paying close attention to the words they use. At least 3. It can be 3, but it can be higher. Then it says no more than 8. And we're still talking about tutoring here. And so we're going to go with X again. But this time we got to go no more than. And so that means 8's got to be like the highest amount. And so we're going to go with the less than symbol, less than or equal to symbol for that scenario. Okay, so far I have 3 constraints on the board. Next, she wants to spend at least 3 hours delivering pizza. Okay, well, that clearly is about pizza. And so we're going to look at the defining variables. We let Y stand for pizza. So we're going to kind of color code this. I'm going to use Y. And it says she wants to spend at least 3 hours. So that means 3 is the lowest she wants to go. She can go higher. So we're going to use greater than or equal to. Alright, and then next, this sentence right here, grab a highlighter here. This one, Julie is paid $10 an hour for tutoring and $7 an hour for the pizza. Now, that sentence that I've highlighted in pink is actually dealing with money. And so that is going to be your function, your objective function from the last set of notes. So that's basically, I'm going to just top it up here. That's going to be like my profit or my cost, either one you want to use, equals, and it's $10 times the number of hours for tutoring. Well, again, X stands for that, so we're going to say 10X. She's going to do both jobs, so plus sign, and then $7 an hour for pizza. So 7 times Y, and again, remember that this one, the last one that I just topped, this one is the objective function and does not need to be graphed. When you are considering graphing linear programming word problems, most scenarios are dealing with positive values. Like in this case, we're dealing with number of hours. So it's not going to make sense for me to get a negative answer. So because of that, instead of drawing like my y-axis here and x-axis here and using all 4 quadrants of the coordinate plane, I know that my answers are going to be positive. So I'm going to go ahead and I would suggest you do the same. Just draw like use a sheet of graph paper, but really you only need the first quadrant since all the points in the first quadrant are positive. And then what I would like you to do is be very, very specific and tell me what the x-axis stands for. And so we're looking at the defined variable part. The x-axis is going to be the number of hours tutoring. And then here, y is going to be the number of hours delivering the pizza. Okay, so just always make sure that you are labeling your axes. And a quick note on graph paper, I would just like use, if the numbers are relatively small like mine, just let every box be 1 unit. And that way you don't have to show me tick marks and the number values, of course. Alright, so what we're going to do is we're going to start by solving these equations, or inequalities. So we're going to go with the first one. And I'm going to have to solve for y. So y is going to be less than or equal to negative x and then plus 12. My slope is going to be negative 1 over 1, and my b is going to be the point 0, 12. Alright, next. The second inequality I see is the one in green. On this one, let me do this. Because there's only one variable here, I'm just going to draw a quick table and actually do that for for the next three, it looks like. Since all three of these next problems do not have two variables, I'm going to use the little table method. And so this is going to be my x, this is going to be my y, of course, and then if x is greater than or equal to 3, think of this like x is 3, and you'll just put 3 in the x column a few times. And then you'll just select your y values, whatever you want to use. And then for this one, x is less than or equal to 8, same deal. Here's my x, here's my y, and I'll use 8 in for x. And then you get to select your y's. And then lastly, I see this constraint says y is greater than or equal to 3. I think of it as y is 3, equals 3. And so this time, I'm going to put the 3 in the y side of the table, and then pick my x's. Okay, so I'm going to graph this one in this pink purple color. I'm going to go to 0, 12. Again, I'm letting each box stand for 1. Okay, so right there is going to be my 0, 12. I'm going to use my slope of negative 1 over 1, down 1, right 1. And you've heard me say this before, just make sure that you're giving me several points all the way through your entire graph paper. And in this case, I just stop when I touch the x-axis. And then I look at my symbol, it says less than or equal to. Equal to means I need a solid boundary. I'm going to just connect those. And less than means shade below. So right now, I'm just going to draw a little arrow and then come back to the shading part. Alright, next we're on to this one. I'm going to do this one in green. It says x is greater than or equal to 3. So that means go to your x-axis, find 3, or just plot 3, 0. Plot the point 3, 1, right 3 up 1, and 3, 2. Okay, so these are just basic points. The symbol says equal, so for the second time, I am going to use a solid boundary. And that's what it looks like. And then this one says greater, so I'm going to need to kind of visualize that everything over here to the right is shaded. Third scenario, third constraint is I need to graph x is less than or equal to 8. So I go to 8, 0. Okay, right there is 8, 0. The next order pair I have in my table is 8, 1. I could have done 8, 2, 8, 3, and so forth. But we can tell it's vertical. And then my symbol is equal to for the third time this problem. So that means I need a solid boundary line. Less than. So less than in a vertical line's to the left. So I need to kind of picture, kind of visualize in my head all of this region shaded. So right now we are below the falling line. We are to the right of the green line, and we are to the left of the black line. fourth constraint. We need to graph y is greater than or equal to 3. So this time I'm going to go to 0, 3. Here's 0, 0. 0, 3 would be right there on top of the y-axis. 1, 3, right 1 up 3. If I had another point, maybe 2, 3, I don't know, 5, 3, whatever the case may be, that's my flat horizontal line. Now that symbol is also equal to, so we need a solid boundary. And there we go for that one. Where it says greater than or equal to, greater is above, so I need to visualize shading this direction. So we'll pause for just a few seconds. I want you to, again, visualize shading this way. From this line, shading towards the right. From this line, shading everything towards the left. And now with the flat horizontal line, shading everything up. And you've got to find the region that's been shaded 1, 2, 3, 4 times. Find the four-sided quadrilateral that's the feasible region. Okay, and if you visualize that correctly, it should be this little region here that I am highlighting. And then, now that we have determined what the feasible region is that contains all the solutions, that means all these ordered pairs, even the ones in between, like all the fractions and decimals, all of those ordered pairs are solutions to these four constraints. Remember, X stands for the number of hours tutoring, Y stands for the number of hours delivering pizza. So even me selecting like a random point that's like a fraction, it's still possible. Like we can work 1.5 hours or 2.25 hours delivering pizza. So keep that in mind. It's okay to get decimals, but it's not okay to get negatives here because of the scenario. But remember from the notes that your max and min, we want to maximize profit. We don't want to make the least amount of money, we want to make the most. And so those are always going to occur at the vertices. Okay, so I'm kind of highlighting those for us now on your screen, and you see 4 points. I'm highlighting in pink. Your job is to now there we go. Your job is to now record that information in a table form. And so like this point here, I would have to start, here's my origin, remember. There's my little origin section, 0, 0. So I have to go right 3 and up 3, it looks like. So 3, 3 is one of my ordered pairs, one of my vertices. Okay, next let's go with this one. I go 3 and then I go up 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 9 is also a vertex for this problem. Next, let's try this one. That's 1, 2, 3, 4, 5, 6, 7, 8. And it looks like up 3. So 8, 3 is a third vertex. I didn't make my table big enough, but we'll keep going. And then the fourth one's here. That is over 8, and it looks like it's up 4. So 8, 4. And then I know I'm writing them down as ordered pair form. That's what you're used to. But always think about your defining variable part. This means she can work 3 hours tutoring and 3 hours delivering pizza. This means 3 hours tutoring and 9 hours delivering pizza, and so forth. In the middle, you are going to bring down your profit. And you're going to substitute your ordered pairs into the profit equation. Alright, so it's going to look like this for the first one. Alright, let me try this. It's going to be, let's see, equals 10 times 3 plus 7 times 3. I'll just model to you 1, and then you can go ahead and fill in the rest of it. But that's going to be 30 plus 21, which is 51. Alright, next it would be 10 times 3 plus 7 times 9. Well, 10 times 3 is 30, 7 times 9 is 63. 63 plus 30 is 93. So we're going to write that right here. Okay, then we're trying 8 and 3. 10 times 8 is 80. 7 times 3 is 21. 80 plus 21 is going to be 101. Next, 10 times 8 is 80. 7 times 4 is 28. 80 plus 28 is going to be 108. Alright, so if this stands for profit, and we're trying to find, the question asks us to find the max, not the min, then these are dollar amounts. Like if she works 3 hours tutoring and 3 hours delivering pizza, she's going to make $51. And so basically you can kind of scroll down and notice that the best option for her is this one. This one's going to create or give her the most amount of money. And so lastly, to answer the question again, find the number of hours she spends doing both jobs for the week to maximize profit. Then you would, the last thing you need to do is just make a general statement. Julie needs to work. And notice the X is 8. Okay, so 8 hours tutoring and 4 hours delivering pizza. Okay, so it's taken a while to show the steps, but once you get kind of the idea in your head, you follow the same pattern. Just make sure that you do answer the question. And then lastly, you actually can always, and I would suggest you do this, always go back and like reread your answer and then make sure it actually works in the scenario. So we got 8 hours tutoring. So let's look for the tutoring sentence. Right here's the tutoring sentence. She wants to spend at least 3 hours. Well, 8 is at least 3 hours, but she doesn't want to spend more than 8. Well, okay, she didn't. She spent 8. 4 hours delivering pizza. Look for the pizza sentence, the one in blue. She wants to spend at least 3 hours delivering pizza. Well, she spent 4. That's at least 3. That's more than 3. And she works no more than 12 hours. And so when you add these two, it's 12. Well, that's no more than 12. So this ordered pair, 8, 4, and this answer does fit the description. Okay, so steps again, follow those exactly like I've done here. Determine the feasible region, the vertices I need you to be really careful on, record them in a table, find your profit from the reading, it's always going to deal with money, and then you answer the question. Okay, so we'll give this a try.